Media access. With many stations on the same piece of network media, there has to be a way of varying for time on the cable. This process is called media access, and there are three main methods: CSMA CD, token passing, and CSMA-CA. Carrier sense multiple access with collision detection, CSMA-CD. This media access technology with the extremely long acronym is probably the most common. When a protocol that uses CSMA-CD has data to transmit, it first senses if a signal is already on the wire, a carrier, indicating that someone is transmitting currently. That's the carrier sense part. If no one else is transmitting, it attempts a transmission and then listens to hear if someone else tried to transmit at the same time. If someone else transmits at the exact same time, a collision occurs. Both senders back off and don't transmit until some random period of time has passed. Then they both retry. That's the collision detection part. The final part, multiple access, just means that more than one station can be on the network at the same time. CSMA-CD is the access method used in Ethernet and wireless Ethernet networks. Token passing. This media access method uses a special packet called token. The first computer that is turned on creates a token. It then passes on the token to the next computer. The token passes around the network until a computer that has no data to send takes the token off the network, modifies it, and puts it back on the network along with the data it has to send. Each station between the sender and the receiver along the network reads the destination address in the token. If the destination address doesn't match its own, the station simply sends the packet on its way. When the destination station recognizes its address in the destination address of the token, the NIC copies the data into the station's memory and modifies the token, indicating it has received the data. The token continues around the network until the original sender receives the token again. If the original sender has more data to send, the process repeats itself. If not, the sender modifies the token to indicate that the token is free for anyone else to use. With this method, there are no collisions as in CSMA-CD networks because everyone has to have permission to transmit via the token. Carrier sense multiple access with collision avoidance, CSMA-CA. This technology works identically to CSMA-CD, but instead of sending the whole data chunk and then listening to hear if it was transmitted, the sender transmits a request to send RTS and packet and waits for a clear send before sending. When it receives the CTS, the sender sends the chunk. Apple Talk networks use this method of media access. The difference between CSMA-CD and CSMA-CA has been described like this. Say you want to cross a busy street and you want to use one of these protocols to cross it. If you're using CSMA-CD, you just cross the street. If you get hit, you go back to the curb and try again. Project 802. One of the major components of the data link layer is the result of the Institute of Electrical and Electronic Engineers IEEE 802 subcommittees and their work on the standards for local area and metropolitan area networks. The committee met in February 1980. So they used the 80 from 1980 and the 2 from the second month to create the name Project 802. The designation for an 802 standard always includes a dot followed by either a single or a double digit. These numeric digits specify particular categories within the 802 standard. Currently there are 12 standards. These standards are listed and described in more detail in the following sections. IEEE 802 networking standards, standard and topic. 802.1 LAN MAN management and media access control bridges. 802 logical link control. 802.3 CSMA CD. 802.4 token bus. 802.5 token ring. 802.6 distributed Q dual bus Metropolitan area network. 802.7 broadband local area networks. 802.8 fiber optic LANs and MANs. 802.9 integrated services LAN interface. 802.10 LAN MAN security. 802.11b wireless LAN. 802.12 demand priority access method. The 802.1 LAN MAN management and media access control bridges. IEEE 802.1 discusses standards for LAN and MAN management as well as MAC bridges. One of the derivatives of the 802.1 is the spanning tree algorithm for network bridges. The spanning tree algorithm helps to prevent bridge loops in a multiple bridge network. 802.2 Logical Link Control. This standard specifies the operation of the Logical Link Control LLC sublayer of the data link layer of the OSI model. LLC sublayer provides an interface between the MAC sublayer and the network layer. The 802 standard is used by the IEEE 802.3 Ethernet specification, but not by the earlier Ethernet 2 specifications used in early implementations of Ethernet. 802.3 CSMA CD. This standard specifies a network that uses bus topology, baseband signaling, and CSMA CD network access method. This standard was developed to match the digital Intel and Xerox DIX Ethernet networking technology. So many people implemented the 802.3 standard, which resembles the DIX Ethernet, that people just started calling it Ethernet. It is the most widely implemented of all the 802 standards because of its simplicity and low cost. Recently, the 802.3U working group updated 802.3 to include Ethernet 100 base P implementations. The 802.4 token bus. This standard specifies a physical and logical bus topology that uses coaxial and fiber optic cable and a token passing access method. It is used mainly for factory automation and is seldom used in computer networking. It most closely resembles the manufacturing automation protocol. Some people think that the IEEE 802.4 standard is for a technology known as the Attached Resource Computer Network, ARCnet. This is an incorrect assumption, although the technologies are similar. The IEEE 802.4 standard more closely resembles MAP, not ARCnet. The 802.5 token ring. This standard is one example of a commonly used product becoming a documented standard. Typically, a standard is developed and then products are written to conform to the standard. Token ring was developed by IBM in 1984, and the 802.5 standard soon followed. 802.5 standard and token ring are almost identical. Like Ethernet, token ring can use several cable types. Most often it is installed using twisted pair cabling, which can either be shielded, unshielded. Shielding adds to the cable investment but offers the advantage of resistance of unwanted electrical signals that could impair the network signal. Possible transmission rates for token ring have increased with time. After 4 megabits token ring came 16 megabits per second token ring. Token ring uses a physical star logical ring topology with token passing media access. If you install 4 megabits per second NIC on a network that otherwise uses 16 megabits per second NICs, your entire ring speed is reduced to 4 megabits per second. Unlike Ethernet, a computer cannot talk unless it has a token. This can cause some grief if a token gets stuck. Unlike ARCnet, token ring is still used in a number of locations for two reasons. IBM made sure that token ring did a fine job of talking to IBM mainframes, which are still commonly used. Token ring performance degrades with grace. The latter means that as network traffic increases, the network slowly gets slower because the single token, which can travel only one direction, gets busy carrying all the traffic. Ethernet, on the other hand, can become so flooded as network traffic increases that the entire network fails. Now suppose you were wiring a computerized fire alarm system for a large building. Which would you rather use, Ethernet or token ring? To increase performance, some token ring technologies implement early token release, whereby the sending station doesn't hog the token, it simply grabs a token, sends its data, and frees the stations to connect. It isn't, however, called a hub. IBM calls it an MAU. IBM often has a different name for things. Even their name for token ring cabling is different. In telephone and computer networks, twisted cable is rated by categories. IBM rates token ring cable by 1 by type. One final difference between token ring and other types is the regeneration process. Data signals are read, amplified, and repeated by every device on the network to reduce degradation. This includes MAUs and NICs, and is one reason that token ring is fairly expensive. The 802.6 distributed key Q dual bus DQDB Metropolitan Area Network. In some ways, asking what defines a metropolitan area network is like asking how long a rope is. We can safely say that a man reaches beyond the area of a LAN. The interesting question is, when does a man become a man? When, like a WAN, a man can support many computers. How many miles a man can cover has more to do with regulation than with geography. For example, from a geographical standpoint, Portland, Oregon, Vancouver, Washington are separated by nothing more than several hundred feet of water. From a political standpoint, they are in different states and therefore different telecommunication regulations apply for each city. This could mean that no mans can connect Portland and Vancouver. For our purposes, we need to know only that a man generally encompasses a city sized area and can support many to many connections. Transmission speeds vary with the size of an enterprise bank account. The standards recommended the use of distributed queue dual bus DQDB technologies for MANs. The 802.7 broadband local area networks. You have already used broadband if you have seen cable TV. When one cable carrier when one cable carries multiple signals, that is broadband. The most common method for separating signals is to have them on different frequencies, which is called frequency division multiplexing (FDM). For example, each channel on a TV uses a different frequency. It is as simple as that. Maybe you can win a beer for some friends by seeing if you can explain frequency division multiplexing. If you can't, collect your reward and tell them that is how all TV channels get into their TV from one cable. The alternative to sending a set of signals this way is to use the entire cable for one signal. This is known as baseband and is used by standards such as Ethernet. The 802.fiber optic LANs and MANs. As the name implies, this working group handed down guidelines for fiber optic usage on networks defined by the 802.3 through 802.6, which includes a fiber distributed data interface (FDDI) as well as 10 base FL. 10 base FL defines Ethernet over fiber optic cable. As you can see, some of the 802 definitions have more to do with your day-to-day work than others. The 802.9 Integrated Services IS LAN interface. For a while it seemed that this definition would have a profound effect on daily networking because it laid out how integrated services digital network ISDN behaves. Late in 1998, however, many industry watchers began to call for the slow death of ISDN because both cable modems and asymmetric digital subscriber line ADSL had overtaken IDSN with less complicated setup, higher performance and lower cost. So I'm going to leave it here today for this video. If you enjoyed listening, please consider like, sharing and subscribing. Thanks for listening.